Welcome to CS3308 Information Retrieval. This is the Unit 4 Lecture Part 1. And during this entire unit, what we're going to be looking at and talking about is the whole idea of how we do scoring, how we do the retrieval of the documents that we've indexed. How do we return them? And one of the ways that we've explored already is really this whole concept of Boolean retrieval, where I go through all of the different search terms. If it's present, I try to return it. If it's not present, I don't. But sometimes it isn't the best method. So in this first lecture, we're going to be kind of covering the concept of scoring. How do I score them from the perspective of relevance? And when I say them, what I'm referring to is all the documents, right? So thus far, what we've been looking at, and most of the examples that we've had in the class have really been around this concept of Boolean queries. And the basic idea behind a Boolean query is the fact that I have a series of terms and I use things such as the and or operator or not operator that basically says if it meets this condition, then it's logically going to be included. If it doesn't meet the condition, then it's not included. So that's the approach that we've had so far in looking at how we do retrieval. Now that doesn't necessarily work, right? Because just because it met the terms of the query doesn't mean it's the best document, right? So in the Boolean model, document either matches or it doesn't. And when it matches, I return it. When it doesn't match, I don't. Now, this tends to be pretty good for expert users that have an exact and precise understanding of their needs and the collection data that they're looking for, and they can be very specific in terms of the query terms that they're using. So let's not discount it. This is actually a very valid and effective method of doing information retrieval, and it works in some situations, but it doesn't work in all situations, which is why we have this kind of point where it's just not good for the majority of users. And the reason why is because most people just aren't all that effective at sitting down and thinking about and developing Boolean queries that are going to get the data that they're looking for. A lot of times they don't even know what they're looking for, right? They don't understand the terms that might be appropriate. So particularly when we start looking at web search or enterprise search engines where you're not quite sure what it is you're looking for, we have to have something that's a little bit more forgiving than what we have in this Boolean model, where I have to know exactly what I'm looking for and be able to effectively use the Boolean operators, things such as and or not, to get the data that I'm looking for and get the documents returned. So again, the big problem with this whole Boolean search oftentimes is that it's feast or famine. I can write a query that is too simplistic and then I get lots and lots of results. And quite frankly, they're not ordered in any ways, right? So on one hand, I can have way too many. I get thousands of results, and none of them are really relevant to what I'm looking for. Or I wind up making it too specific where I don't get any results. And again, the other challenge that we oftentimes run into is there's no concept of like. It's exactly this or exactly that or not this or not that, but not the variability that says I might be looking for this term, but what I really need is all of the things that are kind of like that. Okay, so again, feast or famine tends to be a real big issue with the Boolean model. So the alternative to that, kind of saying if Boolean's bad, what is good, and it kind of boils down to what we're going to call the ranked retrieval model. So the basic idea here is that in rank retrieval, I'm going to look at the terms, and I'm not going to just have an inclusion or exclusion, but I want to kind of look at them and try to determine, are they relevant, or how relevant are they, based upon some calculated metric. Now, when we first started creating web search engines, and this is back in the days of Yahoo, they had this concept of an index, and they had a bunch of people that sat around to try to figure out categories of documents and what the keywords should be for those documents. And quite frankly, it very quickly became unmanageable because there were so many of them. Imagine the job of trying to go and update the categories on a series of web pages or websites when there are literally billions of them. So it didn't work out. So basically where we've gone to is trying to come up with this idea of having free text queries. I can put in any bunch of words, and the system's going to try to determine of that bunch of words which ones are relevant or how are they relevant, and try to return the documents that are most suited to that query or the group of words or terms that I'm putting in the query. So feast or famine, no longer really a problem because it's not a exact match that we're getting in kind of the ranked retrieval. What we're basically saying is we're going to rank the results based upon how similar they are or how well they meet it. Not whether or not they exactly meet it or don't exactly meet it, but if I match one term and that's the only one that I have a match on, well, I'm going to return that document. If I match most of the terms, then I'll return that document. So basically the idea is to come up with a methodology that says based upon the input query that I provided, I'm going to come up with the best fit and I'm going to rank it based upon some measure of relevance. So essentially I don't have the feast or the famine. What tends to happen is I'm going to rank the results based upon how relevant they are, and we'll talk about those measures in just a moment. And then I'm just going to show the top ones, right? So I'm only going to return the most relevant ones. There might be lots and lots and lots of them that are that in some way match the query terms that I have, but I'm not going to actually return those. And in many search engines, the way that it works is that I will have a lot of them, and I'll return the first 20 of them, and then I'll say, do you want some more? And do you want some more? So essentially, again, the idea is we're going to try to identify what is most relevant, provide those to the users, not overwhelm them, and allow them to ask for more if it's required. So the whole concept behind how we do rank retrieval is we go through something called scoring. And the basic idea of scoring is that I have to come up with a measure that tells me for any particular query, is it relevant? So is the document kind of like, or is it relevant in the context of the terms that I provide? And this scoring will kind of measure how well any particular document matches the query. So for example, when we start talking about query and you think about the Google model and you got the box and you put your query terms into the box, and let's say that I'm putting in terms that say home, mortgage. Now, what I would want in this case is I want those documents that are most related to the terms home and mortgage, because I'm probably interested in getting a home mortgage. I'm trying to figure out perhaps what the rates are, or what the terms are, or what kinds of mortgages are offered in the area that I'm at, right? So I'm looking for things that are most relevant to both of these terms. Now, the reality is that in a ranked retrieval model, I could actually get some results that are related just to mortgage, and I could get some results that are related to home. But presumably, the way that this is going to work, assuming, of course, that I have enough documents in my index that actually cover both home and mortgage, I'm going to find those documents that have both home and mortgage in them and are most relevant to this idea of home and mortgage. The central idea in the document is about home and mortgage, right? And those are the ones that are going to appear first. Okay, and as I continue to return and retrieve more results, it may become less and less and less relevant. So maybe I will eventually get down to a document that only deals with mortgage, or perhaps only deals with the concept of home. So we basically need to get to a point of where we can assign a score to a query and a document pair. So I have a document and it has words in it. I have a query and it has words in it. We go back to the example where maybe my query words are home and mortgage. And by the way, I want you to recognize something. When I put those query terms in, for example, home and mortgage, and I type them into the Google search engine, this now creates a document. This is important. We'll get to it later, but just think of the fact that I have just created a document, and the document is relatively short. It has exactly 2 terms in it, and those terms are home and mortgage. So keep that in mind. I created a document by creating the query. So when I go type those words in, that actually creates a document. Okay, so one way of assigning a score, we need a way of assigning a score, I should say, to a query and a document pair. And the idea is to say, okay, I have my query document with its words home and mortgage. And then I have a series of documents that may also include those terms. And essentially what I want to do is I want to have a way of getting a score that says how congruent are these things. Okay? So one of the ways that we start looking at this is we're going to say, one of the measures of whether or not a term such as mortgage is relevant in a document is by looking at how often it appears. A word that appears exactly once in a document may or may not be something that's really relevant to the document. One would think that if you have a document that's about mortgage, they'll probably mention the word mortgage multiple times within that document. Okay, so I have this idea of frequency. And so if the term mortgage does not appear at all in the document, and let's just assume that we're using just one term right now. Let's just look at the term mortgage. If mortgage doesn't appear in the document, then the score of this document is basically 0, because there's absolutely nothing in common between these two. Right? Now, if I add another query term, I got to have some way of weighting those things, right? How much of it is associated with home? How much of it is associated with mortgage? But let's just think about a one-term query, or a query that has one word in there. So I'm going to basically go through and say, how many documents have the term mortgage in there, right? And the ones that have the term mortgage more frequently than other ones should have a higher score, right? Because presumably, if I use the word frequently in a document, that it's probably more relevant in the document. So let's look at a couple of methods, and we're going to talk about a number of different methods of actually doing these scores, right? We've talked about the fact that I have my query terms, and that my query terms create a document in of themselves, and I use the words home and mortgage, right? And then I can go compare these two terms with a document, right? And one of the ways of doing this is by calculating what we call a Jaccard coefficient. And basically the whole idea of the Jaccard is to say, hey, if this is a document and it is a set of words, right? It has some number of words in there. And then I have other documents, perhaps the ones that are in my index, and they also have some set of words. What I really want to do is I want to determine where these two intersect. So, by the way, if you remember this symbol from mathematics and set theory, basically when I have the upside down U, it means intersection. And when I have the right side up U, it stands for union. So think of U as union. So a union is the combination of two sets. An intersection is what elements both sets have in common. So let's kind of look at that. Let's assume that this is document 1, or we'll call this document S over here. And let's say that S had a series of query terms, right? In it, or let's just say it's a document and I just want to measure how similar these two things are. T is a second document, so S is a document, T is a document, and all of these dots represent words that they have within the document. And what we see here is that I have these three points, which would be representative of 3 terms that both documents have in common. Okay, now what's interesting about this is that I have 5 total here, 5 total terms. I have 6 total terms over here, and only 3 of them in common. So one of the things that I can do is a measure of similarity, or to tell how similar these things are, is to kind of look at the ratio of the intersection to the union. So the total number of dots in here is 1, 2, 3, 4, 5, 6, 7. There's 8 total dots within these documents. The union of them are the S union T is equal to 8, right? And the intersection S intersection T is equal to 3. So I've just created a ratio, which is actually 3 over 8, to give me a measure of how relevant these two things are. How similar they are is another way of saying it. And that's basically what the Jaccard coefficient does, is it intersects these two sets and it gives me that measure. Now, we can use that for scoring. So, for example, if I look at these two things, right, Let's say that I put in the terms as a query, Ides of March. I have 3 words here, right? And then I want to compare how relevant is this to a couple of documents. So the first document has Caesar died in March. Now, we can see here that between these two things, there is only one term that is common, right? And then when I look at the other document, I see that the other one, we only have one term that is in common. So essentially, the scores are going to be similar. Now, they're not going to be exactly the same, right? Because this document tends to be longer. This one has more words in it. So if you look at the intersection of query and document 1, it has 1, 2, 3, 4, 5, 6 words, right, in total, of which one of them is common. So my coefficient is going to be 1 over 6. And then in this case up here, I have 1, 2, 3, 4, 5, and 1 in common, so the coefficient is going to be 1 over 5. So the question then becomes, which one is more similar? And the reality is that it highlights a problem that we see in here with using just Jaccard coefficiency, because the problem is that I'm not accounting for the length of the document. So for example, I may have a very short document and have a better looking number than one that's very long, and in fact it may not actually be really any more similar. So it kind of highlights one of the problems we have with the Jaccard coefficient. And again, that's where we're going to kind of get in here is it really doesn't incorporate the concept of term frequency, right? Because we're just basically saying, the sets of words. So I'm not going to count a word if it appears 14 times, etc. So the problem is that it doesn't really have a way of normalizing as well for length. So the length of the document can actually skew this. So, the Jaccard's probably not so good in terms of as a measure for determining the similarity between two documents, or the similarity of a document to a query. So in the next lecture, we're going to look at some alternatives.